Runge Kutta method, consider ordinary differential equation of first order and first degree dy by dx is equal to f of xy with initial condition y of x0 is equal to y0. This method is used to find a solution of y for any given x. So first we know that from Euler method, y1 is equal to y0 plus h f of x0 y0. From modified Euler method, y1 is equal to y0 plus h by 2 f of x0 y0 plus f of x1 y1. Okay, now we are going to use these two formulae to develop the Runge Kutta method for second order. Runge Kutta method second order. Okay, so now from the modified Euler method, from this method we can write y1 is equal to y0 plus h by 2 f of x0 y0 plus f of x1 y1. Okay, now in this equation put y1 is x1 is equal to x0 plus h and y1 is equal to y0 plus h f of x0 y0. Now this y1 we write this value of y1 by using Euler method, and therefore if we put these two values in this equation we get y1 is equal to y0 plus h by 2 f of x0 y0 plus f of x0 plus h and y0 plus h f of x0 y0 Now if we write here f of x0 y0 as, if we put f0 is equal to, instead of f of x0 y0 I am writing here f of f0, then y1 is equal to y0 plus h by 2 f0 plus f of x0 plus h y0 plus h f of f0. So now if you multiply this h inside the bracket, then y0 plus 1 by 2 h f0 plus h time f of x0 plus h y0 plus h f of f0. Now put k1 is equal to h f0 and k2 is equal to h f of x0 plus h y0 plus what is the k1 here? K1 is h f of 0, so y0 plus k1, and therefore this is the value of k1 here, and this is also value of k1, and for this total value we say that it is equal to what? K2, and therefore y1 is equal to y0 plus k1 plus k2 divided by 2. So this is the formula for Runge Kutta method to find approximate solution of y at given value of x, where k1 is equal to h f0 or h f of x0 y0, and k2 is equal to h f of x0 plus h y0 plus k1. So now consider a simple example. Say solve a differential equation by using use Runge Kutta method third to approximate y to approximate y when x is equal to 0.1 and x is equal to 0.2 for differential equation dy by dx is equal to x plus y with y of 0 is equal to 1. So given assume h is equal to 0.1. What is here h is equal to 0.1. So here given f of xy is equal to x plus y, then initial condition x0 is equal to 0, this is the x0, y0 is equal to 1, h is equal to 0.1, and so we want to determine what is the value of y when x is 0.1 and value of y when x is 0.2. So the first we want to determine what is y of 0.1. So now k1 is equal to h f of x0 y0. So h is 0.1 and x0 is 0, y0 is 1. What is f of xy? F of xy, you can see f of xy is x plus y, and therefore this is 0.1, 0 plus 1, which is equal to 0.1. Now next, the value of k2 is equal to h f of x0 plus h y0 plus k1, and therefore k2 is equal to 0.1 f of x0 plus h. So what is x0 plus h? x0 plus h is equal to x0 is 0 and h is 0.1, y0 is 1, y0 you can see y0 is 1, and k1 is equal to 0.1. k1 is equal to 0.1. So if you simplify this, k2 is equal to 0.1 f of 0.1 1.1. So now f of xy is equal to x plus y, and therefore k2 is equal to 0.1 plus 1.1. So it is equal to 0.1 into 1.2. So if you multiply this 1.2 into 0.1, k2 is equal to 0.12. So this is the value of k2. So I am writing here k2 is equal to 0.12. This is the value of k2. k1 is equal to 0.1. Here I am writing k1 is equal to 0.1, and therefore the y1 is equal to the y1, which is a value at x1. So what is x1 here? x1 is x0 plus h. So y1 is equal to y0 plus 1 by 2 k1 plus k2, and therefore y1 is equal to y0 is y0. What is y0? y0 is 1. So y0 is 1 plus 1 by 2 k1. k1 is 0.1 and k2 is 0.12, and therefore y1 is equal to 1 plus 0.1 plus 0.12, it is 0.22 divided by 2, so it is 1 plus 0.11, so it is 1.11. So this is the value of y1. So y1 is equal to 1.11, and which is the value of x1. x1 is equal to what? x0 plus h. So x0 is 0 and h is 0.1, so it is 0.1. So here y1, that is y of 0.1, is equal to 1.11. Now next in step number 2, we want to determine y of 0.2. y of 0.2. So here we assume again the same technique. So here we assume x0 is equal to, for y of 0.2 we assume here x0 is equal to, in the previous iteration we assume x0 is 0. Now we assume here x0 is equal to x0 plus h, that is x1. x1 is what? 0.1. y1 is equal to what? That is y1 is 1.11, and h is same, h is 0.1, and f of xy is what? X plus y. xy is equal to x plus y. So now for the next iteration we get value of y2 at x2. So what is x2? x2 is x0 plus h, that is 0.1 plus 0.1, it is 0.2. So this is what y2, we want to determine y2 at x2, which is nothing but the x0 plus h. So it is 0.1 plus 0.1, it is 0.2. So if you find the value of y2, it gives y of 0.2. So first k1 is equal to h f of x0 y0. So h is what? 0.1, x0 is 0.1, and y0 we assume here y0 is 1.11. So here it is equal to f of xy is equal to x plus y. So this is 0.1. f of xy is x plus y. So 0.1 plus 1.11 is equal to 0.121. If you solve this, we get 0.121, and therefore k1 is equal to 0.121. Next, k2 is equal to, now k2 is equal to y0 plus 1 by y0 what is k2? k2 is equal to h f of x0 plus h y0 plus k1. k2 is equal to h f of x0 plus h y0 plus k1, and therefore k2 is equal to h is 0.1 f of x0. So for this iteration we assume x0 is 0.1, h is 0.1, okay, y0 is 1.11, and k1 is 0.121, and therefore k2 is equal to 0.1 f of 0.2 1.11 and it is what? 0.2 and 1.231. If you add this, it is 1.1 plus 1, 231. So what is f of xy? It is f of xy is equal to x plus y. So it is 0.2. This is the value of x. This is the value of y. 1.231. So k2 is equal to 0.1431. So now finally from k1 and k2 we are going to determine value of y1, or which is nothing but x1, that is x0 plus h. So y1 is equal to y0 plus 1 by 2 k1 plus k2. So y0 is, we assume here y0 is 1.11 plus 1 by 2 k1 is 0.121 plus k2 is 0.1431, and therefore y1 is equal to, if you solve this we get y2 is equal to, that is y1 is equal to 1.24205. So this is what? y1, but this is y1 at x1. this is nothing but at x1, and x1 is equal to x0 plus h, where x0 is 0.1 plus h is 0.1, so x1 is equal to 0.2, and therefore y1 is 1.24205 at x1 is equal to 0.2, and therefore y of 0.2 is 1.24205, and therefore by using Runge Kutta method, y of 0.1 is 1.11 and y of 0.2 is, so what is answer here? Answer, y of 0.1 is equal to 1.11 and y of 0.2 is equal to 1.24205. Now we are going to apply the, this is the y of 0.1, okay, and this is y of 0.2 by using second order Runge Kutta method. This is what? By using second order Runge Kutta method. Now we are going to apply the maxima to solve this Runge Kutta second order method. So first we are going to define f of xy. So what is f of xy here? F of xy is equal to x plus y. Then x0, initial condition is, initial condition x0 is equal to 0, initial condition y0 is equal to 1, okay, and h is equal to 0.1, h is equal to 0.1. Now next we want to determine value of k1. K1 is equal to h into f of x0 y0. So k1 is equal to 0.1. You can see here k1, for the first iteration, for our first iteration, k1 is equal to 0.1. You can see here k1 is equal to what? 0.1. Now next we want to determine k2, which is equal to h into f of x0 plus h y0 plus k1. You can see here the formula for k2 is what? H f of x0 plus h y0 plus k1. So if you enter here, it is 0.12. You can see here k2 is what? 0.12. So the finally y1 is equal to the formula is y0 plus 1 by 2, that is k1 plus k2 plus k2 divided by 2. So it is what? 1.11. You can see here 1.11. Now for the next iteration we assume x0 is equal to 0.1. Then we get the y1 at 0.2. So x1 is 0.1, y0 is 1.11, and h is same, h is 0.1. So k1 is equal to h star f of x0 y0. So it is 0.121. You can see here for second iteration it is 0.121. You can check k1. Now next k2 is equal to h f of x0 plus h y0 plus k1. So it is 0.1431. You can check here. This is the value of k2. And finally k1 is equal to y0 plus h by 2, y0 plus k1 plus k2, plus k2 divided by 2. And now if you enter, it is 1.24205. So hope you understood how to find how to solve this Runge Kutta method in MAXIMA. Okay. So hope you understood. Manually also we get the same answer. In Maxima also it is 1.24205. Thank you.